Good morning, students. Today we will study how to draw molecules in three-dimensional. We had studied two-dimensional representation of molecules by using dash and dot formula, that is called as electronic structure. Then we had studied this condensed formula, then one-line formula. These are two-dimensional representation of molecules. In today's lecture, we will study how molecule can be represented in three dimension. So there are three ways to represent molecule in three dimension. One is Veitch formula, second is Fisher formula, or called as a cross formula, and third type is Newman's projection formula. We will study all these formulae in detail in today's lecture. So most of the organic molecules have three-dimensional shapes. Four different methods are used for writing these three-dimensional molecules on a plain paper. Out of that, one is a Veitch formula. In the Veitch formula, the three-dimensional, that is in short called as a 3D view of the molecule, can be represented on plain paper by representing a single bond using a solid wedge. Can be shown like this. So this is a solid wedge, and a dashed wedge, mean this dot type of lines, can be represented below the plane. Solid wedge is above the plane, dashed wedge, it is below the plane, and a normal line. This type of three types of lines or the wedges can be used. Again, I will repeat. This type of solid wedge that indicates the group which is coming or which is on the plane, above the plane. A dashed wedge indicates the group which is below the plane, and normal line indicates the groups or the atoms they are in the plane. A solid wedge is represent a bond projecting up from the paper towards the reader, and a dashed wedge is used to represent a bond going backward below the paper away from the reader. So solid wedge towards the reader, this dashed wedge is away from the reader, and the normal line depicts the bond in a plane of the paper. We will see this example given in the figure 14.1. Here, see this, it is a Veitch formula for methane. We know methane is the first example of alkane. Here at the center there is one carbon, and there are four carbon hydrogen bonds in methane molecule. See this normal line with two hydrogen that indicates the bonds in the plane of paper, and this wedge, solid wedge, that indicates the bond projecting above the paper, and dashed wedge that indicates the bond going below the paper. So on the two-dimensional paper or the plain paper, we can represent three-dimensional geometry of molecule using solid wedge, dashed wedge, and normal lines. Again, I will repeat this here. Normal line indicates the bonds are present in the plane of the paper, and the solid wedge that is above the plane, and dashed wedge, it is below the plane. In this way, on the two-dimensional paper, three-dimensional geometry of molecule can be shown. The second type of formula to show this three-dimensional geometry is a Fisher projection formula, that is also called as cross formula. In this representation, three-dimensional molecule is projected on a plane of paper. The Fisher projection formula can be drawn by visualizing a molecule with its main carbon chain, which is a vertical, and each carbon on the vertical chain is represented by a cross, meaning is, in short, a cross indicates the carbon. So convention is that the horizontal lines of the cross represent the bond projecting up from the carbon, and the vertical line indicates the bond going below the carbon. This is shown clearly in this diagram, that is in the wedge formula. This solid wedge, these are the horizontal lines, and that represents the bond projecting up, and the dash wedge, these are the vertical lines that indicates the bond going below the carbon. But actually in the Fisher projection formula or cross projection formula, this type of solid and dashed wedge are not shown. Remember this well. If there is a horizontal line, then these bonds are above the plane, and vertical lines, these are bonds below the plane. So this is one example. The second example is, it is, see here, first group is COH, second HOH, third is HOH and CH3. Of course, at the cross section of these lines, vertical and horizontal, there is a carbon atom. Actual wedge formula can be shown here: COH, then CHOH, CHOH and CH3. See here, the vertical bonds, these are below the plane, that is shown with the help of dashed wedge, and horizontal, that is a solid wedge, horizontal bonds, they are above the plane. And in the Fisher projection formula, these are all are normal lines. Only remember that if it is horizontal, then above the plane. If it is vertical, then below the plane. So that's very simple. So Fisher projection formula is more commonly used in carbohydrate chemistry. So that carbohydrate chemistry is given in 12th standard. There we will study in detail this type of formula, Fisher projection formula, and one more, that is a Newman projection formula. Now we will study here Newman projection formula, third way to write this formula of compound in three dimension. In this method, the projection of three-dimensional molecule on the plane of paper is drawn by visualizing molecule by looking through a carbon-carbon single bond. In such a case, the carbon-carbon is not visible. If you observe, if you look through one carbon, and which is other carbon is backside to that front side carbon, then we cannot see this carbon-carbon bond. A convention is followed to represent the front carbon by a point and rear carbon by a circle around it, because that cannot be visible. The remaining three bonds at each of these two carbon atoms are drawn like the spokes of wheel. The conventionally three bonds are at the front carbon are shown to radiate from the center of circle, and which is front carbon, and 3 bonds from the circumference of the circle that indicates the backside carbon. This figure 14.3 shows the two representations of ethane molecule by this method. We know ethane is CH3 single bond CH3. See in this first figure at the center, these hydrogen are shown. That indicates at the center there is a front carbon on which 3 hydrogen atoms are bonded with equal angles. Then the rear carbon, backside carbon, is not seen because we are looking through carbon-carbon bond, and therefore backside carbon or the rear carbon is shown with circle, and the bonds of that second carbon with hydrogen, they are shown at the circumference of the circle, and these are again 3 hydrogen, one behind other. It looks like one behind other. Or if we move this one carbon atom, or if we rotate one carbon by keeping other carbon at fixed position, meaning it's this front carbon is at the fixed position and rear carbon is rotated through 60°, then we can see clearly this type of structure in which front carbon, it remains the same as given in the first structure, but the second carbon hydrogens, they are having the clear angle, that is rotation shown by 60°, and clearly all hydrogens are at the equal positions, that is seen in the structure second in the Newman's projection formula. So this type of Newman's projection formula can be drawn. Then the fourth way to represent this type of three-dimensional geometry of molecule on the plane of paper is called as a sawhorse formula, that is also called as a Enderon formula, or also called as a perspective formula. In this representation, again a carbon-carbon single bond is represented by a long slanting line. The lower end of the line represents the front carbon, and the upper end of the line that indicates the rear carbon or backside carbon. The remaining 3 bonds at the 2 carbon atoms are shown to radiate from the respective carbons. As the central carbon-carbon bond is drawn rather elongated, the bonds radiating from the front and the rear carbons do not intermingle. The figure 14.4 shows the two sawhorse or Enderon or perspective formula of ethane. See this figure number 14.4, that is structure 1. Here it is similar to this Newman's projection formula. First carbon at the center and 3 hydrogen atoms are shown. Then there is a one line, slanting line. At the end of this slanting line, there is a second carbon, and again there are 3 hydrogen atoms. Here, by keeping the front carbon at the same position, the second carbon hydrogens are rotated through 60°. Then we can see the second structure. Now the hydrogens are clearly visible from front and second carbon easily. So this type of structure, that is called as a sawhorse formula of ethane. So in this way, today we had studied how to draw molecule in 3 dimension by 4 different methods. First is Wedge formula, second is Fisher projection formula, third is Newman's projection formula, And fourth is Sawhorse formula or Enderon formula, also called as a perspective formula. If you make the practice of this, how to draw this different types of three-dimensional geometry for the molecule, then it is very easy to draw the three-dimensional structure of the molecules. Thank you.